Ho, 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 Merry Christmas. That's right, it's that time of year. In my class, we are dealing with systems of equations right now. And what I'm asking my students to do is look at a system specifically written in standard form, both of my forms of these equations written in standard form. Can we determine if it would have one, none, or infinite solutions? Naturally, most of my students are going to want to graph both of these lines, see if they cross at one point, if they're parallel lines, or if they're the exact same line. But without even having to graph on a piece of graph paper, we can determine this by just looking at these equations in slope-intercept form. Here's a quick refresher. If you already are here watching this video, you should know slope-intercept form is y equals mx plus b. Okay? This is kind of your key code over here. If it's going to have infinite solutions, when you rearrange it into slope-intercept form, you're going to come up with the exact same two equations. Because if you think about it, if the two equations are the same, the lines would be the same, they're going to be right on top of one another. No solution, we would have the same slope, but we'd be starting in different places. Our y-intercepts would be different. So if you look at this first equation, we're starting at -9, rising 5, running 1. On the second equation here, we're starting at 3, so we're starting in a different spot, but we're rising and running at the same rate of change. Those lines would never cross. They're going to be parallel lines. Same slope, different starting point would create parallel lines. And one solution just means your slopes are different. So if your two slopes, when you rearrange these two equations, are different values, automatically you know right then and there that it has one solution. So let's dig a little deeper and see if we can figure this out. I always like to just work off the bottom equation, then I'll rewrite the top equation down here to work downward. Okay, I'm going to subtract 8x from both sides. That's going to leave me with 3y on the left, -8x, and -2. Remember, those two terms don't go together. They're not like terms. This has an x, this does not. Okay, we need to divide by 3. Divide by 3, cancels, divide by 3, divide by 3. And I'm left with y equals a negative divided by a positive is a negative. So 8/3 x. Negative divided by a positive is a negative. We'll keep that as 2/3. So right now I know my slope is -8/3. If I'm going to answer no solution or infinite solution, when I rearrange this here, I should get -8/3. Because if I have any other slope other than -8/3, those lines are rising or dropping or running at different rates. They're going to cross at some point on the graph. So let's rewrite 2x plus y equals -1. 2x plus y equals -1. We're going to rearrange this so that y is all by itself. All we need to do is move that 2x, subtract 2x from both sides, and you're left with y equals -2x minus 1. Now my slope here is -2, my slope here is -8/3. Don't even need to do any more thinking or graphing. Because my slopes are different, these lines are going to cross at some point. Now if you're asked to figure out where that point is, graph that line, and just see where they intersect. Study hard. Systems are not easy, but the more practice you do, the better you're going to get at them, and the quicker they will become. I know it seems like a lot, but get the practice down. You're going to do just fine. Study hard. Good luck on your upcoming test.